Hello everybody, how are you? Today we'll continue with projectile motion special cases, special cases. Uh, yeah, I've discussed about the angle, the angle at which, the angle at which R range and y max are equal. I told you theta, we calculated theta to be tan inverse of 4, and theta is about 76 degree. So when you project an object to air at angle theta 70 degree from the horizontal, you will have equal horizontal and vertical displacements. Horizontal and vertical displacements. It may be a kind of this one x and this vertical axis y, and you may have y max and range. So this and this, the vertical displacement and the horizontal displacement, y max and r are equal when the angle of projection, the initial angle of projection, theta initial is 76 degree. We calculate this one using the equations for maximum height and maximum x displacement, which is range, and we found out it to be tan inverse of 4, which is 76 degree. 76 degree. And today we will continue with two more special cases, okay? Two more special cases which are related to range and maximum height. Range and maximum height. Just if we try to see, from an experimental point of view, let's say you projected an object with some initial velocity. Here we fix, okay? Fix your initial velocity, okay? To be some fixed value, finite or a small value. So you start to project with a very possible small angle, and you get such. You try to increase the angle, and you increase both the range and the height. You increase the angle. Let me say you do it with some angle. Okay, we have theta 1, we have theta 2, and let me say we have theta 3. So from calculation, I will show you that at some angle you have the maximum range, and when you increase the angle, the height keeps increasing, but the range starts to decrease. You increase the angle, basically you will have smaller range and longer height. longer height. Oh, sorry. You will have longer height. And if you keep increasing the angle, finally you will have theta 90 degree, which shows you project the object vertically up and it will fall back with a range 0. Okay, with a range 0. So with smaller angles you have smaller ranges and heights. At some point you will have the maximum range, and at vertical projection automatically you will have the maximum height and the minimum range, or zero range. Okay, let's see what theta 3 is. What is theta 3? What is the angle of projection at which the projectile will experience the maximum range for fixed initial velocity. So what we know for such projectiles, what we know is y max is, we have calculated this one. You can refer to the previous videos. It is going to be v naught square sine square theta over 2g. I told you fix the angle, the initial velocity, which means you need v square over 2g to be constant. Okay? So what varies is theta. And we know that sine theta varies between -1 and 0. -1 and +1, sorry. -1, 0, +1, all values in between. It is -1, sine theta is -1, okay? Sine theta is -1 at theta is equal to 270 degree. And sine theta is +1 at theta is equal to 90 degrees. Okay, 90 degrees. This is from trigonometry. Therefore, what maximum value for sine theta and sine theta squared actually is at theta is equal to 90 degree. The maximum value of sine theta is 1, basically means y max is maximum. Okay, maximum when sine square theta is 1, which means y maximum basically is v square over 2g. Therefore, for your maximum height, theta has to be 90 degree, and it is vertical projection. Okay, this is one special case. When the initial angle of projection is 90, the maximum height is the maximum one. Okay, the maximum possible height for all angles from 0 to 90, because we are going to use either 0 or 90 or in between for angle of projection. Basically, when theta is 0, it is not projection. Okay. But for 90, it is vertical projection. Vertical projection. So one case is this one. The other case is what is theta 3? Where the range is maximum. The range is maximum. And we know that a range of such a projectile is calculated as 2v naught square sine theta cos theta over g, or we can reduce this one as v naught square sine to theta over g. Sine to theta, better to use different color here. Okay, for those the marker. Sine to theta. We know that twice of sine theta cos theta is equal to sine to theta from trigonometry. Okay, that's how we reduce the equation to this one. And again, R is maximum, which is v naught square over g when sine to theta is maximum, which is actually 1. Is that not? Because the maximum value for sine is 1 for 2 theta. So sine theta is 1 when theta is how much? 90. This implies 2 theta has to be 90 degree. Then theta is going to be 45 degree. So at 45 degree initial projection, okay, you will have a maximum range. So this angle theta really in our diagram has to be 45 degree. 45 degree. So you will have maximum range at 45 degree initial projectile angle, and you will have maximum height when you project an object vertically up, which is angle of projection is 90 degree. Okay, so whenever you deal with projectile motion, okay, this may help, and you can include time. At what angle? At what initial angle of projection? Okay, at what initial angle of projection? At what initial angle of projection the object stays long in air, okay, which means T total is, we know that twice of V naught sine theta over G. Twice of sine theta over G. So the question is, for T to be maximum, what should be theta? What should be theta? Then sine theta is basically maximum when theta is 90, and therefore it is still going to be vertical projection. For theta is equal to 90 degree. For vertical projection, for vertical projection, the object it stays long for the same velocity. Physically, you can say because it is going to move up against gravity, its velocity decrease, and it will come back. There is no constant or uniform motion. In that case, only uniformly accelerated motion is happening, and we will observe a reverse motion, okay, upward projection and free fall. Due to that, the time is going to be longer if you project an object vertically up at 90 degrees, keeping the velocity fixed or constant. Okay, these are special cases which can help you to see details of projectile motion discussions. And I think this much is enough for today. And until we meet with another video, enjoy this video and thank you.